Testing. Okay, hello. I assume I would have passed the test. So here we have a circuit that we were also building. And this we call the MUX or multiplexer. It's a very popular circuit. If we actually come over here, there are plexes. The system comes with its own multiplexer circuit. We're building our own. So we take a look at this circuit and we see we have a NOT gate here, an AND gate, an AND gate, AND gate, and we have a NOT gate. We have this pin down here called a selector. I'm going to the finger of simulation, and I can turn this to a 1 or 0. Notice when it's a 1, the bottom AND gate has a 1 coming in here, and we don't know what's coming in here. Let's say it's a 0. 0 and a 1 is a 0. And if I follow it out here, I have a 0. Notice when the channel 1, the input 1, imagine this is data. The data is just flowing. I don't know what this is. Maybe someone's talking and this is their speech quantumized and turned into binary codes just coming out of here really fast. And now I want to hear what's coming in over here. But look, channel 0 is blocked at the gate. When I change this selector to 0, follow the 0, it comes up here. The 0 has the effect of turning off this bottom AND gate. The 0 also goes to this top NOT gate, becomes a 1, and it has the effect of telling this gate, hey gate, whatever channel 0 is, you're going to be. It's like multiplication. This is 1 times x is x. Down here it's the same thing. This is like 1 times x. Channel 0 is x, and channel 1 is x. X is x. So no matter what happens, channel 1 is x, and it just effectively is a copy of x. When I go to 0, whatever's up here, it's coming out. So notice in our minds, we see that this first gate is turning on and off. This NOT gate is flipping the value back and forth. This thing's turning on and off, and this is inverting the value. But it looks like the output is exactly matching the input of channel 0. And channel 1 is ignored. I switch. Channel 1 is now going to the output, in effect, but channel 0 is ignored. This is a multiplexer. And I may love this circuit. I say, gee, I'd like to use it again. Oh, darn. Okay, if I want to use it again, I could copy, Control C, Control V, paste, and I got this monster to deal with. Yuck. What I'm going to do is I'm going to say File, Save As, and I'm going to call this MyMux. Now I'm going to go up to File, Project, Load Library, Logisim, MyMux, Open. Now I see a chip called MyMux. Drag this over, and if you take a look at it, the pins that are here, the blue are input, the red is output, it kind of matches this. I'll drag over this bubble, drag over, whoops, I said drag over an input. Looks like I'm going to have to move this down a little. Another input. So I now have 2 other channels. Now I need a selector. I need this to face up here. So I'm going to the selection area, the attribute, have it face north. I said click, have this thing face north. I don't know why it's not facing north. Oh, wrong one. North. I changed the text by accident. This is text. So I'll give it a name. I get south on the bottom. Call it S. There's our selector. Give this a name. I'll call it D0 for data 0 coming in, data channel 0. And this one, I'll call it data 1 for data channel 1. I think I'll make them both uppercase D's. I think it looks better. There we go, D0, D1. Switch to the finger of simulation up here. Notice I selected channel 0. Channel 0 flows out. Channel 1 is ignored. Switch. Oh, this is pretty cool. So I'm going to do something. I don't need this big thing anymore. Get rid of this. Whoa, this mess is so big. So here I switch to another one of these. Now I have 2. Look how much space I'm saving. It's incredible, isn't it? So now I have 2. Same exact things. Control C, Control V, snap. Control C, Control V, snap. I said snap. Control C, Control V. Get that in there. Snap. Control C, Control V. Back to the simulation finger. Oh gee, what I could do is, suppose I needed a bigger multiplexer. I could drag these over. I said drag these over. Let's say I'll delete that. Take that wire. Now I have now notice I have 2 controls, an S here and an S there, so I'm going to give these S's different names. I'll call this S1, and you could probably guess I'll call that one S0. And I go to simulation 0, 0. Let's see, nothing, nothing. So 0, 0 is this one up here, so I'll change that to Z0, 0. Next, I'll say what happens when I pick 1. Nothing, nothing. So I'll call that one D01. So this will become D01. Now, what happens if I make this a 1 and that a 0? It'll pick this channel. All right, so that's D, that's a 1 and a 0. So this D becomes a 1 and a 0. But what if I pick a 1 and a 1? Nothing, nothing, nothing. Whoops. A 1 and a 1 picks D01. So there are 2 possibilities for D01. Anytime I pick a 1 from this channel, this thing comes straight out. So we might be able to fix this with some logic or leave it as is, but it's pretty cool. Later we'll fix this in class, make things nicer. And of course this can now go into a chip, save as MyMux 321. So I go File, Project, Logisim, MyMux 321. So notice now we have this chip. Excuse me for being silent. It will do everything in the other chips. So I'll do something fancy. I'll use a LED here. But otherwise, this might be faster than drawing. These 2 chips are now in parallel with each other. That would be the phrase. So that the bottom chip does, this top one does. So we'll go to the simulation. I have 0, 0. Notice they both do whatever D00 does. Nothing happens, nothing happens. Let's do 1, 0, combination 1 and a 0. Nothing happens, nothing happens. They both do whatever D10 does. So what do we know? This one chip up here encompasses all the logic down here. And this is basically what starts to become computer architecture or logic systems. We take simple ideas and we make more complex ones. All right, we'll end it here.